Hi, this is the video for Lab 5, which is the lab with the experimenting with the BJTs. So for starters, we're going to do part B, which is just a current source, and the main takeaway from this is that no matter what resistance value that you have for the potentiometer, right now it's at 1.8K, your VE, so the voltage across this blue resistor here, is going to be constant, and the current is also going to be constant. So just to show when we did this, yeah, so 1.59 volts, and that was pretty consistent for every value of the resistance that we used. But VC is going to change. So as the resistance increased, I believe VC went down. So right now it's at 2.15 volts. So yeah, then part C is also set up on the breadboard right now. I'm going to do part A in a separate video later. So part C is a voltage amplifier. So what you have a resistor running from a power source, which in this case should be 5 volts. It's running through two resistors, which are both in series of 1K, so that represents a 2K equivalent resistance. They're running into the collector. Then into the base, you're actually putting the signal that you want to amplify. So we're running a 0.5 peak-to-peak wave from Digilent right now. And the collector, you have a 1K going out, and the amplification is based on the ratio of this resistance into the collector over this resistance into the emitter, and it's also negative. So this is 2K and that's 1K, so we would expect a gain of around 1. So if you look at when we actually run the network for this, hopefully this works. Right, okay, so the blue line on top here is what we're really looking at. So that, when you, a gain of about 2, like RC over RE, if you convert that to decibels, you get around 6, which is admittedly very hard to see here, but that's about what we're getting. So that's good. That is what we want. So the DC offset difference, if we had one, would basically just make like the waveform. It would make the waveforms here like offset, like it would start at 0. It wouldn't start at 0, it would start at like a different voltage value, but we don't really have one, so we don't have to worry about that too much. And just another quick note on phase. It's at around 180 right now, and that's just representing the negative in the gain, essentially, I believe. I think that's everything for now. Okay, so we just did part B, and part A is extremely similar, except we use like slightly different values, and we used the lab power supply instead of the Digilent one, but it's essentially the same thing. So what you have is a resistor, is a potentiometer here, but no matter what the resistance is, the output current is always going to be the same, and that happens by varying the voltage VC, and just basically the voltage varies to keep the current the same regardless of the resistor value. So just to show you the measurement, right now the resistance is 1.8K in the potentiometer, so VC is around 6.91 volts, and VE is at around 4.60 volts, which is also about what it was at every other value, potentiometer value. So yeah, I think that's basically it for part A.